So my name is Manu Ravishankar. I'm an associate director in the energy systems team at Carbon Trust. I'm also the project manager for the Flexibility in GB project. I will dive into some of the key insights from this work and discuss this from an infrastructure perspective. We also have a panel discussion straight after my presentation to pick up and unpack potentially how we can do this in practice. So as an overview of the session, we're going to be using some of the insights from the work that I mentioned. And in doing so, we'll be looking at some of the key challenges relating to meeting net zero, the value of flexibility in easing this challenge. We look at the capacity and the type of flexibility that is required. And then given the core theme of this session is looking at the infrastructure coordination and development challenge, we're going to look that through kind of three main areas. One is the importance of local and national coordination when operating flexibility. The second is the value of cross-vector integration across the energy system, i.e. between the power, gas, and the hydrogen systems. And then we end the presentation looking at some of the precursors for cost-effective hydrogen deployment. So before I dive into the analysis, I'll just start off with a quick overview of the project. So the Flexibility Great Britain, the report is now available publicly for download. It is hosted on the Carbon Trust website. It's on the front page. The report essentially sets out to understand the role and value of flexibility in meeting net zero targets. In doing so, of course, it has helped to create a robust evidence base to support the continued deployment of flexibility technologies. It provides a continued direction to the market and the policymakers on the role of flexibility in a cost-effective transition. And going beyond the modeling, it explores the business models for flexibility and also the other enabling requirements that is required to make them deliverable and viable. And of course, this project could not have been possible without the support of the partners across the energy sector, whose logos you can see below. And the work, of course, was done in strategic partnership with Imperial College, whose integrated whole energy system model underpins all of this analysis. So I would like to start off with a quick overview of the modeling approach to set the context for the results, which I will go through in the next few slides. We have taken a scenario-based approach to modeling the role and value of flexibility in 2050, given the uncertainties. And we chose the heat decarbonization strategy as the main aspect to differentiate the three core scenarios. So we've looked at a hybrid heating scenario, an electric heating scenario, and a predominantly hydrogen-driven heating scenario. For each of these core scenarios, we carried out a systems analysis of high flexibility deployment and low flexibility deployment to work out the system cost and other implications. This allows us to not only understand how much flexibility and what type is required, but also implications for generation capacity, the type of generation that we need, the carbon negative technology requirements, network investments, and so on. We also undertook a range of sensitivities given the uncertainties in system development, which you can see in the icons at the lower part of the slide. We looked at the different hydrogen production routes, and in that we also looked at the level of coupling that hydrogen and hydrogen-related technologies can enable. This is something that we'll pick up later in this presentation. We looked at the impact of availability or unavailability of carbon negative technology and the implications for wider system, and similarly looked at the impact of flexibility technology availability. For example, if we do not have demand side response, or if batteries becomes too expensive, or if you're not able to deploy the level of thermal storage required. We also then looked at a local versus national optimization. This again is picked up in this presentation. And finally, the impact of having a zero and a net zero carbon target on the energy system and associated costs. So I'm going to take a few minutes to start this presentation off, focusing on the net zero challenge from an infrastructure perspective, given that's the theme of the discussion today. Now, these charts are from our modeling, and given there are a lot of scenarios, I've used the electric heating scenario under a low flexibility to illustrate a few key numbers to set the context for this discussion. The electricity demand in this scenario, as you would expect, is significantly higher at around 790 terawatt hours, and which is significantly higher, of course, than what the current demand is. And as reference, the 2019 electricity demand was around 345 terawatt hours. Now, this entails significant electrification across the board, which of course is part of the infrastructure challenge. And this involves large-scale equipment replacement, new technology deployment, process modifications, and so on. Another facet of this that is important from an energy infrastructure perspective is peak demand on the distribution network, given the rise in electricity demand that we are seeing. Now, this figure in 2050 is around 228 gigawatts. Now, this is a significant rise from the current levels and drives additional network reinforcement and investment that is required to kind of meet this demand in a secure way. Now, the generation capacity that is required, which is the chart on the left, is another key challenge given the overarching target of meeting net zero by 2050. Now, we've assumed in the analysis that the energy system will need to deliver a net negative emissions around a negative 50 million tons per year to offset any emissions from sectors that are hard or too expensive to decarbonize by 2050. Now, this drives the total generation capacity in 2050 to be up to 419 gigawatts without additional flexibility installed. And again, as a reference, in 2019, the total installed capacity was around 103 gigawatts. This was also during the time a few coal plants retired. But still, this is a 4 times increase in 30 years that is required in a full electric future. Now, this slide outlines the cost impact of adding additional sources of flexibility into the system. As you can see from the percentage reductions, that it helps to reduce the cost of the system in all the 3 core heating scenarios. There are several components of whole system cost that is covered in this modeling that includes generation, networks, capital and operating expenditures, and other investments that is required, such as in end-use equipment and or flexibility. Now, the list of these cost components can be seen on the right-hand side of the figure. There is significant cost benefit ranging from around 16.7 billion pounds per year in 2050 in the electric heating scenario, owing to the peak demand increase and the generation capacity required in the counterfactual that we saw a few slides ago, to around 9.6 billion pounds per year in 2050 in the hydrogen scenario. This difference in system cost savings is owing to the greater flexibility that is available in the future, such as in the hydrogen scenario, where there is an inherent ability to decouple hydrogen production and demand, which makes it more flexible inherently. Now, these cost savings are delivered by flexibility that helps to meet the demand more cost effectively. We'll look at the details of how exactly this is done in the next slide. Therefore, the key message is that while there is a significant infrastructure challenge, flexibility helps to ease this infrastructure challenge. So here again, we dive into the example of the electric heating scenario, and then we see the impact on the total demand and also on the generation capacity. As some of you might have noticed, there is a significant reduction in gas capacity in the high flexibility scenario. That is the second column on the chart on the left. And now the addition of around 80 gigawatts of storage, which is in black color in the chart, displaces around 90 gigawatts of unabated gas generation. Yes, you still need over 120 gigawatts of combined cycle gas turbines, but the total capacity of the gas generation fleet is significantly lower when flexibility is added. Now, it is important to note that the build out of the system is really driven by some key capacity adequacy requirements in the modeling, particularly during a high demand, low supply event in the winter that we have assumed. Now, there is a 72-hour period in the modeling in 2050 where the demand rises to around 230 gigawatts, coincident with outputs from offshore wind and PV dropping to less than 5% of its maximum generation output. Now, of course, this drives the large build out of gas plants that are able to come online, mostly during these periods of stress. Now, this is another key challenge in terms of delivering a net zero system in a cost effective, but also a secure manner that can weather typical and atypical events. Now, we found that a combination of gas and battery storage is a cost effective way to deliver during this peak demand and low renewable energy supply period. Using unabated gas, of course, has implications on the carbon emissions, which then necessitates the deployment of carbon negative technologies like bioenergy with CCS, direct air capture. I mean, the direct air capture capacity is not mentioned here, but you can see it as in the light blue in the demand stack figure on the right hand side. Now, demand shifting via demand side response and other flexibility technologies also helps to reduce the peak demand on the distribution network, which, as we mentioned a few slides ago, really drives the network investment required. So the peak demand, when flexibility is added, is reduced from 228 gigawatts to 166 gigawatts. Now, this is slightly more than a 25% reduction, which is significant and, of course, has implications on the cost and the level of reinforcement required. So the key message here again is that flexibility helps to ease the significant infrastructure challenge by optimizing generation and the network investment required. Having seen the high level value of flexibility and its impact on key aspects of infrastructure such as generation, networks, and demand, we turn to looking at what types of flexibility really enables this benefit. This study, as shown in the modeling overview, we picked up at the start of this presentation, considers a range of flexibility technology across supply and demand. You can actually see the different flexibility technologies that are deployed on the legend on the right hand side of this chart. Now, the first key point is to say that we always see a portfolio of flexibility technology deployed across the core heating scenarios. Now, as you can see from this chart, there are significant levels of flexibility deployed. Between 70 and 175 gigawatts of flexibility on the power side, and between 149 and 211 gigawatts on the thermal side. Thermal storage technologies, of course, is better measured in gigawatt hours sometimes. So for people who want to do a quick calculation, we've assumed a 6-hour duration for thermal storage in the district heating side and a 1-hour duration for thermal storage on the building side. Now, this is actually a key consideration for using flexibility in the most optimal way to minimize whole system costs. Thermal storage, for example, helps to decouple production of heat and the use of it. This means that heat pump can run at their full capacity outside their peak periods effectively, which helps to reduce the peak demand and therefore the generation capacity that is required to support that. We can thus see the value of flexibility on the thermal side, providing immense value to the power system, outlining the critical need for coordination between power and heat. So, turning to the other aspect of flexibility capacity portfolio is that a large part of it comes from demand side sources. The chart here grays out those that are interconnection and battery storage capacity, as of course one is akin to transmission networks and the other is predominantly utility scale, but actually still connected mostly to the distribution network. Now, this portfolio is a significant change to how flexibility is provided currently, which is of course predominantly large generators like gas power plants that sit on the supply side. Now, this creates some very interesting challenges. One is the role of energy networks in helping to deploy this flexibility effectively and quickly. As you can see, there is a lot of it. How do we develop compelling consumer value propositions and engagements, given these are mostly embedded within heat mobility or even everyday appliance solutions? And finally, how do we effectively coordinate these many distributed assets to derive maximum system benefit? So, for example, does the sector's digitalization strategy allow for this level of distributed coordination? These are really interesting themes, and I would like to pick up some of these questions and discuss this with our panel, who of course represent the energy sector, to get their views. So beyond the flexibility technology portfolio outlined in the previous slide, we also looked at the other ways of coordination between the gas and the power system and how they can work in sync. Now, there are 4 scenarios outlined in this chart, and all of them are based on a full hydrogen heating scenario. The first 3 columns from the left are a low flexibility scenario, while the 4th one is a high flexibility scenario. Now, going from left to right, there is sequentially more coupling allowed in this system. So starting from the left, only existing coupling scenario on the far left has only current forms of coupling, which is predominantly via gas power plants. The next column, which is partial additional coupling, is where we've added electrolyzers to simulate a one-way coupling wherein the power system delivers the required electricity to the electrolyzers that makes hydrogen, which then gets re-injected into the gas network to meet heating and other demands. This one-way coupling, as you can see from the chart, helps to reduce the cost by around 5% or 5 billion pounds of total system cost per year in 2050. Now, moving on to the third column from the left, it is a full coupling. So this has a two-way coupling in that we mean that it has electrolyzers and also hydrogen turbines. So this means that the gas system now delivers the required amount of hydrogen into these plants, which produces electricity that helps to meet any electricity demand during peak or outside peak periods. Now, this two-way coupling saves an additional 1% or about 0.5 billion pounds per year, which is still material. Now, the use of electrolyzers and the hydrogen turbines reduces the system cost by actually reducing the amount of natural gas required in both the hydrogen and power production, and of course, therefore, has a knock-on implication on the level of carbon negative technologies such as direct air capture that is required to offset emissions from these activities. And finally, the last column is where we have a two-way coupling and additional forms of flexibility as outlined in the previous slide that allows further coordination through having technologies like thermal storage, vehicle to grid, and so on. Now, what this does is that it pulls together heat, transport, power, and hydrogen effectively for system benefits. Now, this coordination is really translated into system savings. As you can see, it helps to save an additional 9% of whole system costs, or actually around 9 billion pounds per year in 2050. Now, this slide is very similar in layout to the previous slide, and this showcases a similar effect of coupling that is helping to reduce system cost and meeting net zero. But this time around, we're looking at the electric heating scenario. So as you can see, again, going from left to right, we see a similar trend of cost reduction progression going from existing levels of coupling between the power and the gas networks all the way through to kind of full coupling where you have flexibility and the hydrogen technologies that are pulling together the different systems, which offers, of course, the greatest step down in terms of cost. So as you can see, there's about a 13% whole system cost reduction per annum in 2050. Sorry. So this reaffirms the value of coupling, and to highlight that this is not only valuable in scenarios that predominantly use hydrogen, but as we can see, it is also immensely valuable in a full electric heating future. So now that we've looked at the type of energy infrastructure coordination that is required and its value in different scenarios, it is really important to look at another key aspect of coordination, which is local versus national. As we know, local area energy planning is becoming even more prevalent, with local actors taking more action and responsibility for coordinating and planning the energy system at a subnational level. This is critical for us to meet net zero. So for this analysis, we have essentially considered two scenarios. One, which is locally optimized, which is the column on the left, wherein we mimicked an energy system that focuses on minimizing costs within its own boundaries. Now here, we use the local distribution network costs as a proxy for these local costs. For the whole system optimized scenario, the column on the right, this is a system that is seeking to reduce cost for the UK overall system rather than any one part of it, like distribution networks or generation. Now, the key result here is that focusing on just local optimization could increase the cost overall by 1%. While this might seem as a small percentage, the absolute costs is pretty material on an annual basis in 2050. Now, the total increase in cost is really due to an increased expenditure on low carbon generation, additional investments in heating solutions, storage, and also heat storage. This offsets any savings that have been made on the reduced capacity for fossil fuel generation, distribution costs, and also resistive heating. Now, there's also another key insight in terms of the change that is happening in the energy system makeup between these two approaches to system development that is actually happening in the background, which we did not see picked up in terms of costs. So a locally optimized system actually needs 20 gigawatts of additional battery storage and actually a significant increase in distributed renewable generation. So for example, the solar PV capacity more than doubles from 55 gigawatts to 129 gigawatts in a future where we only focus on local system optimization to meet the same total demand. Now, what this shows us is that while the cost increase might not be immediately perceptible or significant, the system that is optimal actually might be far more difficult to deliver in terms of the number of things that we need to do and the associated complexity in doing so. Now, this highlights the need to ensure optimal investments in local distribution network capacity to reduce the whole system cost by enabling more effective access to generation and flexibility across the energy system. So while local energy system development is critical, it needs to take into account whole system benefits to ensure there are no unintended consequences. So I would like to finish up this presentation talking a bit about hydrogen, on which we have some really interesting insights, particularly on the infrastructure aspects and its relation with flexibility. I will also be going into this in a little bit more detail in the afternoon session. So the chart on this slide shows the total system cost of a hydrogen dominant heating scenario. So the first and the third column show scenarios where all the production methods of hydrogen are available. So for example, electrolysis, gasification, steam methane reformation with CCS. And this portfolio is optimized by the model, and there are no other constraints on enabling technologies. The second and the fourth column are scenarios where we have constrained the availability of carbon capture and storage infrastructure. This means that the hydrogen production is just reliant on electrolysis. Now, focusing on the first two columns, we can see that the whole system cost increases by around 18% in the case of the scenario where CCS is not available and hydrogen production is just from electrolysis. Now, the same effect can also be seen in the third and the fourth column, but it is important to note that the whole system cost, even when CCS is not available, is lower by about 11 billion pounds per year. Now, the increase in costs in both these scenarios is down to an increase in cost towards much greater electrolysis, which, of course, in 2050, as per our assumptions, is a more expensive way of producing hydrogen than the other production methods. But the system impacts, particularly relating to the scale up of the renewables required to supply the zero carbon electricity, is also another key implication that we need to be aware of. So actually having flexibility in this system helps to reduce this challenge. There is around 60 gigawatts of capacity less required in the scenario that relies on just green hydrogen, i.e. with electrolysis, with flexibility compared to the one without. Now, from an infrastructure perspective, the other interesting point to note is that in the lowest cost hydrogen system, which is the third column from the left, there is around 10 terawatt hours of hydrogen storage deployed and used in 2050. Now, this is a critical enabling infrastructure that is required to unlock the benefits that we're seeing. Because what this does is this allows the system to produce hydrogen at the lowest cost and at the right time and store it, and then discharge it for when it is needed most across the system. So this, in a sense, is kind of decoupling hydrogen production, which has an impact on the electricity system, and hydrogen use, which has impact on kind of thermal and industrial demand. So that's 10 terawatt hours of hydrogen storage used in 2050. So for reference, there is around 40 to 50 terawatt hours of gas storage in the UK currently. As you can see, there is a lot of infrastructure aspects that we need to take into consideration, and it is a theme that I would like to revisit during our panel discussion. So I would like to finish up the presentation with the final few slides. The first one is bringing all the key messages together. So what is the summary of key insights for infrastructure development and coordination for net zero that we can draw from our work? The first one is flexibility helps to ease the infrastructure challenge across all the net zero future energy scenarios analyzed. Having a portfolio of flexibility helps us to reduce the backup generation. It helps us to optimize the network investments, and also overall helps us to reduce the cost of heat and transport decarbonization, which are critical elements of net zero. The third point is that flexibility is significantly more distributed in the future, and actually it's very cross-sectoral. It sits across power, heat, transport, and hydrogen. The fourth point is that the whole system benefit maximization is and should be a key objective for flexibility assets, even if they are deployed locally to reduce infrastructure costs right through the system. Finally, there is material monetary value in greater coordination of power, gas, and hydrogen infrastructure across the different core energy scenarios. And Hydrogen development needs to be coordinated across the production methods, storage use, and CCS infrastructure to make it as cost effective as we can. Finally, there's a lot of details in the report, and across all the sessions starting on Tuesday, we were able to cover different aspects of it, but by no means have covered all the details. So if you'd like to have more details and dig into the analysis a little bit more, the report can now be downloaded on this link, or if you go to Carbon Trust webpage, it's right on the front page. And to give you a sense of what this covers, the first chapter essentially sets out an overview of the GB energy system and also tells you a little bit more about what are the different forms of flexibility. Chapter 2 discusses the integrated whole energy systems model, which of course is the critical analytical underpinning of all this analysis, and also the scenarios that we modeled. Chapter 3 sets out the results of the modeling and also the value of flexibility that you see in these different futures in 2050. Chapter 4 takes it beyond the modeling and considers what really we need to do to actually deploy flexibility by 2030 and examines the barriers for developing these different forms of flexibility. And chapter 5 sets out some of the recommendations, but also looks at what areas of future work is required, given this is an extensive piece of analysis, but still there are some research questions that we need to look into. And the appendices will be available in a few days' time. It will describe the IWES model in a little bit more detail and also be very transparent about all the assumptions that we've used in this analysis. So if people want to kind of look at the assumptions in the context of the results, please feel free to do so, and all of the information will be available there. So that ends my presentation, and then we can move to the panel discussion now. Great. I think I can see everyone now. Can everyone see me?
We can. Indeed.
Perfect. So I'm really excited to discuss this topic with the panel that I've kindly assembled today, of course, representing the electricity and the gas infrastructure. And so we have a great coverage across the energy system to discuss this critical aspect of the net zero transition. So I will start off by introducing them and asking them to provide a personal introduction to themselves, their role within the organization, and also maybe a little bit about the organization in itself. Maybe Stathis, can I start with you?
Yeah, absolutely. That's fine. So hi everyone. Nice to be here. I mean, I know most of the people on the panel here. We worked in various shapes or forms. I'm energy markets lead for UK Power Networks. I mean, the idea is that we are developing the flexibility capability within UK Power Networks along with the other DNOs as well. And we are pretty much defined our vision for flexibility generally since 2017 when we published our Future Smart consultation, and then progressing this through the flexibility roadmap in 2018 and running flexibility tenders. And given where we are effectively with the ED2 process and the RIIO2 framework that Ofgem has provided for us, I think that the topic of flexibility is very interesting and is one of our core plan for ED2 and beyond, because this is not a problem for just what we do in one price control or another. It's pretty much a policy direction to achieve net zero. So whether we talk about individual plants at the distribution level or whole system solution, electricity, gas, heat, etc., this is effectively where we should be in and what should be aiming for. So I'll park it out there. I mean, we can talk about flexibility a bit more detailed during the panel conversation anyway.
Absolutely. Thank you, Stathis. Mel, could we come to you, please?
Yes, hello everybody. My name is Melanie Bryce and I'm the Oxfordshire Programme Director at Scottish and Southern Electricity Networks, and also the lead on Project LEO, which is Local Energy Oxfordshire. And I represent distribution part of SSEN, so that's from the cutout in your home right the way through to the grid supply point for anyone who's not quite so familiar on how the distribution is categorised. So the Local Energy Oxfordshire project is very much accelerating net zero through enabling flexibility across the whole system. And I'll be telling you some more about it during the panel discussion. Thank you.
I really look forward to that, Mel. Could we go to Keith next?
Yeah, good morning, everyone. Keith Owen. I work for Northern Gas Networks, and I'm head of systems development. Very much involved in the whole future outlook of the energy systems transition, looking at how we decarbonise the gas industry, working with colleagues from right across the distribution and transmission sector. Previously led our H21 programme, which was looking at how we convert our entire network to 100% hydrogen. I now lead a project called Integral, which is a whole systems environment where we can really start to create that sandbox and understand the interactions between gas, electricity, and the other utilities and so forth, and what that means for the consumer. I also, on this particular project, on the GBFlex project, represent Institution of Gas Engineers and Managers, which is more of an industry representation into the project. And within IGEM, I chair the Hydrogen Standards Committee, and what that's looking at is the 70 plus industry standards which guide us and allow us to manage the utility infrastructure in a safe and appropriate manner. They're all geared up for natural gas, naturally, and the work that we're doing at the moment is how we transition those standards to have hydrogen supplements initially, but then have them as standards in their own right to guide industry, provide that science, that research, and that good practice to push down into the gas industry. So an awful lot of work going on. You'll probably hear more about that through the discussion, so I'll stop there and hand back to Manu.
Thank you, Keith. Yeah, really excited to have you to kind of bring that gas and hydrogen perspective into this discussion, because as we've seen, this is really a kind of coordinated and integrated approach that we need. So thank you for joining the panel. And finally, to Roger.
Yes, good morning, everyone, and thanks, Manu. Great presentation. Thanks for sharing that with us. I'm Roger Hay. I'm Electricity System Manager at Western Power Distribution. Western Power Distribution is one of the 6 DNOs in Great Britain. We've got 7.9 million customers covering the Midlands, the southwest of England, and South Wales. We pride ourselves as a business on our sort of exceptional customer service and really trying to keep everything really simple for customers. So that's a key sort of element of sort of flexibility for us as well. I'm fortunate enough to be leading a team that's responsible for making our grid even smarter and more flexible to support the delivery of net zero. So that includes things like digitalisation, all of our smart control systems, monitoring, smart metering, and a bunch of other new technologies. I'm also responsible for new connections, or what's now called system access. Of course, it's not just about getting access to the system now and having a sort of fixed consumption. We want to be able to make people can access the system to deliver flexibility back as well. So that's making quite a change to some of the ways that customers will access the system in the future. And last but absolutely by no means least, part of our job is making sure that we run a zero carbon system, which we do in large parts of our grid already at certain times of the year, that the grid is stable, secure, safe, reliable, and that the lights ultimately stay on. And as we become even more reliable on electricity for things like heat and mobility. We've been really supportive of this sort of whole system work, proud to have supported this study. And it follows on from a number of other engagements we've done both with Carbon Trust and Imperial College, perhaps most notably our Freedom Project, where we worked Wales and West looking at optimisation between gas distribution and electricity distribution grids. And it's fantastic that your new modelling is also showing that when you optimise 2 types of flexibility, you don't just add them together, actually they magnify each other when you put them together. So a great piece of work, and really pleased to join you.
Brilliant. Thank you, Roger. So I think let's begin the panel discussion with a pretty big question, actually, but I think that'll open up this panel around infrastructure quite well. So The report, of course, outlines the value of a cross-vector and sector approach to delivering flexibility to ultimately kind of reach net zero targets at the lowest cost. And a couple of kind of interesting examples, I guess, is flexibility embedded within heating and transport infrastructure is able to coordinate and kind of help the power system deal with extreme periods cost effectively. And this, of course, we're already seeing a lot of the value of this cross-vector integration. So I guess from a network infrastructure perspective, how do you actually see this materializing in practice? And also, what enablers do we need to put in place to move towards this coordinated approach? Perhaps I can start with Roger to get your views first.
Yeah, absolutely. Well, I'd probably start by turning that around. So while a lot of flexibility that we do today starts from the point that we have a problem, the grid is congested in an area, or we have a capacity margin shortage. Absolutely, going forward, this should be not about helping the grid. This should be about helping customers. So how do we keep customer bills as low as humanly possible and deliver them an exceptional energy service, be it a heat service or a mobility service as well? So I think for me, the key to this is creating this sort of dynamic and agile marketplace for consumers to be able to buy the energy services of their choice at the quality and the price of their choosing. Letting the industry, us and energy suppliers and aggregators and energy services companies take all the kind of complexity away, keep it nice and simple for customers, and either deliver them lower bills or a better value proposition. For example, a newer or faster car for the same price, for example. So let's focus on value rather than fixing a problem. That's how I start.
Brilliant. Yeah, that's a really good point, Roger. And I think some of the themes that you picked up around kind of delivering a marketplace and consumer propositions are really interesting themes that I want to pick up again. But to kind of maybe open this up as well. Mel, do you want to come in on that?
Yeah, I'll come in probably more around the sort of whole systems approach. So as part of Project Leo, we've got representation from pretty much every part of the end-to-end electricity process that's going to be required to deliver flexibility. So we're really able to delve into some of the issues that are there in providing what it is that Roger's just described. And the things that we're learning is that we need to have, the basic things like a common language and common knowledge across these different sectors and common ways of working. So we're really investigating that as part of the project. And that should lead to things being cost effective and coordinated. So as part of the project, we are looking at the markets as well, which Roger just mentioned, but also the sort of system analytics side of things as well. And one of the key themes that we're going to have to explore and support is that of open data. So how can we support the proactive sharing of data, across the whole system so that we can extract that best value? And then I think that the third thing I wanted to mention was the mindset. This is very much a people thing. It may be assets, it may be wires and cables, but it's all about people and behaviors and organizations wanting and being able to contribute across the whole system. So we're going to need support from the government to make sure that local authorities have the ability to engage with other parts of the whole system infrastructure. We're going to need support from businesses so that we can coordinate across local objectives. And we're also going to need support from Ofgem for things like the local area energy plans and making sure that they are well embedded into our price controls, such as ED2.
Yeah, thank you, Mel. I think some really important facets there, as you said, just even having common language of how we talk about the system. Each of us have our own perceptions of our part of the system, but I think that's sounds quite simple, but it's probably quite profound of how important that we need to get that right. So maybe, moving on to Keith, do you want to come in on that question as well?
Yeah, thanks. Really interesting points made so far, and I've been crossing off those exact points because I was make the same. But that they are really important, the customer element and so on, to get that right. I guess just more widely than that, there are the fundamental operational considerations to be understood here. As we start to bring together align gas and electricity systems, we are opening up new failing modes, we're opening up new markets, and so on and so forth. So really understanding from an operational perspective, what is the safety position for any interconnected system, be that electrolysis plant or whatever. What are the standards that has to be applied to that are applicable both from a gas and electricity viewpoint, and of course those be very, very different. We've heard about open data, absolutely support that, and understanding what we mean by data. I'm very conscious that when we pull in information metrics back from the gas system, that's on a different timescale, different level to what we see in the electricity system. So if we're trying to match inputs from both sides, there's a technical aspect to be looked at there. I think from a regulation perspective, there's clearly some changes needed, either from the safety regulatory processes to support the conveyance of hydrogen onto the gas grid, or from a commercial and a code perspective, tweaks to what we have now in order to support these new industries coming along, so that they can be enablers to the commercialization. So these new installations stand up in terms of commercial model, requiring as little incentive from government as possible, and all of that needs to be interconnected. How do we pull all of that together? It's a completely new area for all of us to get involved with. So that common language, as has been talked about, that sharing of information, collaboration, I think is going to be essential in order that the correct commercial, operational, physical arrangements are in place to make this whole systems approach get off to a really good start and provide the levels of flex needed.
Great. Yeah, thank you, Keith. Yeah, really, really interesting and important points, as you said. Even simple things like, are we getting standard formats of data shared between the two systems to take the right decisions at the right time? So yeah, thanks for that addition. Status, can we come to you?
Yeah, sure, definitely. I would say everything. I ticked all the boxes, right? Everything is said. So I don't have to say anything about it. No, I would stick initially to the knitting. I mean, in the sense that, as we as UKPN and being a DNO have a core responsibility to operate and develop the network, as efficiently, individually and collectively across pretty much all the DNOs, which I think Roger touched upon. Whether you use infrastructure or markets is pretty much how we're trying to achieve that. So the idea is that then you actually try and facilitate and bring all the parties that use and connect to the network towards net zero, and that's kind of the goal up to now. Now, the beautiful thing, I think, which is already happening, is the mindset is already changing at policy level. And the whole idea of embracing a whole system perspective, which is we only start seeing now in a regulatory framework, the whole system perspective brought from Ofgem, is one we are embracing. We kind of do it already in the current price control. This is going to become even more prevalent, I think, in the next price control needed to, and even beyond that, where effectively we kind of put everyone in the same, let's say, room and try to think, okay, you have a gas system, you have an electricity system, how you bring that together to manage the net zero. I mean, there will be questions, and it's going to be the harder policy decisions there to come about, for example, how do you repurpose gas networks and all that. But the idea is we actually, as networks here, try and facilitate that and deliver that and help all the parties to come together. So yes, you do it through data, you do it through markets, you do it through infrastructure. But the idea is that's the good thing is actually we're already in that mindset and we're already working towards that end. So I don't want to spend more time repeating everyone else, but I think that's the core message we are all driving here for, right?
Yeah, no, I think there's a common language, I guess, developing, which allows you to tick boxes quickly, which is good. So I think, but that's a really important point, Status, and it's quite good to hear as well that we don't necessarily need to wait for regulatory signals to start taking a whole systems approach. That actually it is actually happening organically through the work that you guys are doing, either through innovation or business as usual. It's
Even
almost
man, just to add there, I mean, for example, we have example where we work with a local gas distribution network, for example, in the Isle of Dogs, where I actually live. Right, we are already working with that. We are working with National Grid on various projects, right? We work with WPD on neighboring substations. I mean, there is that ongoing cooperation already, right? So we are that's the good thing about it, right? That's what I'm saying. I mean, we shouldn't. If the audience is someone is there, or the audience is thinking, are these people only talking about the future? What I want to let the people understand is that we're already doing it, right? Just it's not going to start; it has already started.
Yeah, no, that's really good to hear, and that we're moving in the right direction, and there's already momentum there. So I'd like to pick up one point which always comes up in these discussions around coordination, which is what is the kind of role of digitalization, and do we have a kind of strategy in place to actually allow this level of coordination, data exchange, operational method, safety, etc. So maybe Stathis, given that I kind of came to you last and you had a lot of boxes ticked off, maybe I'll come to you first in terms of how important is digitalization, and how much of these complexities is it going to help us address?
I mean, digitalization is how you actually make the data available to yourself first, but also to the parties that are going to be using them, right? And the parties might be using them, might be people that connect to the network, but also other network or system operators. So I can tell you, yesterday I was in a workshop with the ESO trying to figure out how we're going to coordinate our actions going forward in order to dispatch the most efficient solution to manage both the distribution and transmission system in electricity, right? So that's effectively part of digitalization, how you bring effectively, stuff that have been traditionally done as, okay, I have paper, so where I have my outage planning for the network, and how do I make that in a digital form that I can send to someone in the control room of electricity in Wokingham, so they know how to manage the constraint. We have a transmission level then the day after or a week after. So this whole process is actually is part of what we are actually delivering as well, and we need to keep doing more of it. I'm not saying it's done; it's a done deal. The data we exchange today will be different to the data we will be exchanging in 5 years' time. They have to be closer to real time, so they present more closer what the network is doing and the system is doing across both electricity and gas. So yeah, digitalization is the way to get to net zero. Right? It's one of those ways of getting to net zero.
Okay. Thanks, Stathis. Mel, are there some interesting insights coming out of Leo in terms of kind of role of digitalization that enables these complexities to be managed?
Yes, no, definitely. I think, across the whole system, because it's the whole system we're talking about, there's definitely different variations in advancement when it comes to digitalization. So say, for example, some of the aggregators might have quite advanced digital capabilities. But then, for example, when you come to the distribution networks, we are having to install monitoring equipment and that sort of thing on our low voltage network to understand exactly what's going on there. So there are different levels of advancement across the whole system. And one of the challenges is getting them to be more in sync with each other so that we are communicating and have available the levels of data that are actually required. And I think we also have to remember that we are coming from a very technical angle, being DNOs. We are most familiar with the volts and the amps and how they flow. And we're moving more into a system that's going to be run on the basis of markets and understanding the data that's going to be required for those markets and the sort of price signals that are going to be coming out. That's going to be ever more important as we move forwards. And that's some of the things that we're investigating through Leo, the sort of prices that people who are participating in the trials are willing to either exchange their energy at, or their capacity, or facilitate in more the DSO service markets. So I think it's important to recognize that we're moving into a different area, and we will be needing a lot more market information as well as system information to be available and exchanged across the whole system.
Great. Yeah, thanks, Mal. Yeah, definitely multiple kind of levels of digitalization. It's definitely not homogeneous. So that, yeah, I completely agree. And maybe Keith, coming to you in terms of digitalization, I guess historically gas networks kind of managing gas pressures, and of course you have a lot of flexibility in kind of line packing and things like that. Kind of moving forward into the system, as we've seen from some of the analysis, there's a lot of coordination between kind of when to produce hydrogen, lining up with kind of renewable production, storing it, using it, and also coordination of all of those operational elements with the power system. So what is kind of digitalization? How important is it a role from kind of the gas networks perspective as we start to move towards developing hydrogen as well?
Yeah, it's certainly seen as an enabler for net zero. We've got a number of projects looking at digitalization right now. We've just, in fact, we've more or less completed a major upgrade of our internal systems in order to be ready and to manage data more effectively. I think looking out across that whole systems piece, I think that there are a number of key areas that we need to really start to focus in on. I think we heard a little there from Mel about one of the areas, which really is, if we consider the systems that we have now, and I'm sure it's the same for gas and electricity, where we have the issues and where we have information and what we're monitoring now may not be the same in a few years' time. So we really need to think about what sort of information we do need. Because one of the challenges with this new digital technology, it's so much easier to do things these days and more cost effective. There's a risk here that we're pulling in information just for the sake of it, and it's not targeted and focused in the right place. So I think there is a need to undertake work there to really establish what are the key essential pieces of information that are required, both from that singular purpose of managing effective gas supply networks, but then how does that play into the wider community, both electricity and indeed the customer? Because what we're seeing now is, again, because things are an awful lot easier with these new incredibly powerful digital technologies, sharing of information, providing greater access in that open data we heard a little touched on earlier, providing that sort of information becomes a really credible thing to do, and something that needs to be looked at carefully so that the right information is available, the necessary data protections are in place, and so on and so forth. So it really is understanding what is that evolving picture so that we get this right. Now, that's quite a significant undertaking, and we all are focusing very hard on exactly what that will look like. I think in addition to all of that positivity around it, we do need to have a very keen eye on the added risk that digitization brings. So there's a huge amount of positives there in driving out cost, more efficient, better information, and so forth. But equally, it opens up new failure modes to the system when you start connecting all of this together. It opens up new risk in terms of cyber intrusions and so forth. So there's an awful lot to consider to make sure that the adoption of these very sophisticated technologies really drive that business change and drive the lower cost and the benefits back to the consumer.
Yeah, thanks, Keith. I mean, that's definitely a theme I want to pick up again in terms of kind of resilience and security of supply. So I'll definitely, pick up that question again. So maybe Roger, coming to you on this point, I think you mentioned in your first opening remarks, the Freedom Project was incredibly interesting because you kind of sat across that kind of power and gas side and kind of coordination of something that you kind of explored during the innovation project. What kind of insights did you get on kind of digitalization needs to kind of enable this coordination?
Yeah, digitalization is becoming the latest sort of buzzword, isn't it? Just, in danger of, all you need to say is digitalization, and that means you've ticked the box. But what we learned, Manu, really was the key to this is creating markets and delivering those customer propositions. The relationship for sharing data with other organisations, this isn't 1998 and a regulated distribution business sharing data with a regulated retail business. The relationship's completely changed. So if we try and build our digitalisation and data sharing around legacy data flows, it's going to fail. So it's a completely different requirement. It's actually different for different groups. We've got traditional B2B type relationships. We've got an awful lot of what I call sort of .com, which is these sort of emerging agile ESCOs and stuff coming through. That's a very different requirement for sort of process data in the form of information. And what's quite new to networks is also the sort of business to customer angle as well, which again is a different type of sort of data surfacing again. For customer perspective, while we're talking today about effectively around sort of energy infrastructure capacity and optimization, the benefits of digitizing networks don't stop at getting access and avoiding building sort of excess capacity. They all support things, in our case, on the electricity side, things like power cut restoration, being able to know who's off supply from smart meters, ping smart meters. So you get customer service benefits in those areas. You get much better information for us to be able to plan the grid around new connections and system access, and we can make that data available. We can use the same data and digitize grid information, things like asset health, which can have significant value as well. And of course, never forgetting that part of our job is to run an efficient grid and to keep our electrical losses as low as possible. And so all that data sort of helps in those things as well. So flexibility is really, really important, but digitalization and digitalization go a lot further than that in terms of the overall package of all the operations that we deliver.
That's great. Thank you, Roger. I think that's a great summary of the kind of value of digitalization, and also not using that as kind of silver bullet to solve everything. So maybe moving on, the other aspect that I wanted to pick up, which again, we just presented upon, which is the importance of kind of local area energy systems. And I think we heard from Stathis that things like that are happening in his home turf. So one of the key insights from the modeling is that while local area energy system is really important, keeping that national perspective is a critical aspect of it, which delivers kind of overall cost reduction. Otherwise, you could end up having potential unintended consequence of making the local energy system cheaper, but the national system more expensive, and also delivering the local system potentially becomes a little bit more complex. So the question that I guess I want to pose is, as all of you are involved in some levels with kind of supporting local area energy system development, given that you're a key actor in that space, how do we really ensure a whole system perspective is maintained as we still promote bottom-up energy system development? So I think I'll start with Mel on this one. Mel, if you want to come in.
Yeah, no, thanks, Manu. So reading through this one, as part of the project that I'm looking at, we've never really thought of it as optimizing locally and then optimizing nationally. We've always thought of it as optimizing across the board, because I don't think the two can really be separated. I think they are totally interlinked, and the enablement of the small and many at the very local level is going to help at the very highest level. So for me, the two things are totally interacted, and the value stack that we can propose by a whole system approach and not just a local approach is much larger, and therefore the uptake that we're likely to get. So for example, I saw in some of your slides that demand side management is a large part of flexibility that we're going to need to get to net zero. One of the things we're finding through the project is that actually enabling that is really very tricky. We have a lot of buildings in the project, getting in behind those building management systems, seeing how we can actually flex them and what level of flexibility they have against a baseline is quite difficult to do. And the more value that we can extract from the whole system and not just say deferred reinforcement on the distribution system, the more likely we are to get participation and therefore be able to enable that in our transition to net zero. So for me, it's more of a virtuous circle. We need to do more work with communities to get to our net zero ambitions. So that's how I see that piece working out. And I think we've also got to recognize the fact that we are learning by doing across the board with this, and that we need to make sure that we have our safe, secure and reliable electricity supply, but we need to be able to understand that it's very dynamic and the whole thing is changing. And going into ED2, there's still a great deal that we we really don't know and that we need to find out in order to enable the small and the many at the very local side of the grid. And probably the last point I want to make is around energy efficiency. I think we've got to remember about energy efficiency at the local level, and really engaging with communities and people and driving forwards energy efficiency. We did a study with Regen recently, and they were saying there's about a 27% reduction against a baseline that we can get from energy efficiency alone, and that has, you know, multiple benefits across local, across smart, across fair, across all these things that we want to promote. So for me, it's more the two have to work together, and I don't think trying to optimize one against the other is a very useful approach in this particular scenario.
Great. Yeah, thanks, Mal. Absolutely. I think that lines up exactly with kind of how we're looking at this in the analysis as well. Maybe coming to Roger, do you agree? Anything else to add, Roger, on this?
Well, we've been involved in, obviously, we've been supporting a number of local area energy plans being developed as our sort of business planning process for 2023 to 2028. But we've also sort of previously participated in a number of sort of forerunners of that, probably most notably the Smart System and Heat Programme, Energy System Catapult down in Bridgend, which did some great modelling on sort of optimisation between gas, electricity, and potential for hydrogen and district heating as well. I mean, what we've learned on that project, and a similar one that we've been trying to do in the West Midlands, is it's really, really difficult. There is no clear responsibility or accountability for overall sort of energy planning in a locality. You know, even where you've got a you know, devolved regional body like the West Midlands Combined Authority, you find that they might be responsible for transport, but they're not responsible for heat, for example. Heat is still responsibility of the local authorities. So yeah, it's still really difficult, but it's an absolutely critical role that somebody locally takes the views of consumers into the sort of long-run services that we will be investing in. This isn't one size fits all, and this isn't a case of doing absolutely everything at minimum cost. This is about doing things at a cost that customers feel is good value for money, and that is likely to vary across the country, between urban areas, rural areas, north, south, east, west, and so on. So the key thing is the stakeholder engagement. But yeah, I would welcome greater clarity on the responsibility for local area energy planning. We'd certainly like to do much more.
Great. Yeah, thanks, Roger. I think it's a critical aspect. I mean, the Carbon Trust does a lot of work in local area energy planning as well. Absolutely right. I think that having someone kind of responsible for that is actually critical. That can kind of pull together the different information and then figure out what is optimal. Is definitely a critical part of that planning. So maybe coming to Stathis, I think you already mentioned, I think, around the DSO, ESO conversations that's been happening in local energy. It will be really interesting to hear more on that.
No, absolutely. I mean, I will take what Roger just said about stakeholder engagement. I mean, that's how pretty much you start building the work towards a whole system perspective. I mean, one thing we have done through stakeholders, I mean, I can bring some tangible examples here, given kind of mentioned it earlier. In our flexibility tenders, for example, we as UKPN, but all the other DNOs as well, are pretty much allow other parties like electricity suppliers, aggregators, storage providers to build on the revenue provide for local flexibility with anything else they can do on the whole electricity system, right? That's one clear example. And that's why I was saying earlier, this is something that people need to go away and think that this is already happening. There is also the other thing I said, you know, the forward-looking stuff we are doing with National Grid, for example, as an ESO to manage through the regional development plan, the South Coast, where we have a lot of interconnectors, which you touched upon in the analysis you presented. Like, you know, these are part of the stuff that deliver the net zero and ensure both, you know, security of supply, sustainability, and pretty much also the affordability element. I mean, to the different customer and consumer proposition and the value around it. One thing we haven't touched upon is a useful example. I mean, on a UKPN level, we have even, you know, flexibility contracts with the water utilities, right? So that's water is not so much considered as part of that, but actually it is, because they consume a lot of energy to bring water to pretty much our taps, right? And they are part of that. So us getting them on board and facilitating their move into our flexibility pretty much serves both the electricity payer, but also the water bill payer, and pretty much the same individuals at the end of the day, right? But it's again helping towards net zero, right, one way or another. So I think we do have those examples, and we are working to that, and stakeholder engagement by all means is the way to do it.
Yeah, thank you, Sadhus. I think that amplifies the kind of need for effective stakeholder engagement and kind of bringing the kind of multiple parties into fold who you may not normally assume have a big role to play in the energy sector, but actually they do. So yeah, maybe coming to Keith, I guess the question to you on this would be, one, how much do gas networks get involved in local area energy planning? And also we see from a hydrogen perspective, I guess, the development of local clusters, which is it's a very bottom-up development that we're seeing. How do we kind of ensure the kind of national benefits and coordination, in sync with this kind of local development?
Yeah, I would certainly reiterate everything that we've heard so far in terms of engagement. I class it as it's really about people and places, understanding the needs of the local community, the local industries, and so forth, and making sure that there is a concise and clear route to be able to deliver that level of service. Certainly, from a Northern Gas Networks perspective, and I'm pretty sure that the other networks operate in the same way, we have quite a lot of engagement with local authorities, commenting on local area energy plans and so forth, and that's really key, because it's very clear from the heat agenda and to a degree transport, but certainly for heat, which obviously we have a key focus on. There are a lot of different options out there. There's not a clear line of sight as to what works best in different scenarios. So having those ongoing conversations to really understand how all of this might connect together is absolutely essential. And I say that people in place mindset, I think, is essential to be able to deliver against that. I just thinking more widely about your question there, and this does relate back to very clear connected policy positions. So that's both a local policy and a national policy, which can really support and enable all of the players that are involved in this, be that large industry, small industry, local authorities, utilities, and so forth. That's the sort of level that we need to get to, so that you have this cohesive approach. But thinking about the people in the place, that connected policy, you almost start to move towards the consideration of both the local and national system architecture groups who meet, really drive these local energy plans, allow us to have a much more synchronized view of what the next 5, 10, 15 years are, because some of these infrastructure projects, certainly, well, for all of the utilities, can be quite long-term in terms of their ultimate delivery. So getting that long-term view down to that local level is really quite important, so they get a sense of the direction of travel and can map what their ambitions are to do that, or indeed we can map to theirs. So I think those two things are very important. Just to touch on one area which I think is equally essential in all of this, and it's really about skills and competency, and just very conscious that there is, the UK has always had a bit of a skills shortage, particularly on the technical side for utilities and other industries. So really having a sharp focus on how we rebalance that, how we get the people with the necessary mindsets, capabilities to be able to work in a whole systems environment, I think is going to be crucial, because without those skills, those competencies, that immersion in that sort of way of working, we'll still end up with very siloed thinking, very siloed approaches, and not deliver the best outcomes for customers. So there's a lot to be done in that space too.
Brilliant. Yeah, thank you, Keith, and thanks for everyone. I think that's got some really interesting perspectives on kind of how we coordinate local and kind of national energy system development for the benefit of the customer while kind of bringing all the actors together. So I think that is really helpful. So I see there's a kind of few audience questions coming in as well. So maybe I'll just kind of move on, which is something I think both Keith and Roger picked up on, which is the how do we ensure security and resilience in a system that is going to become more integrated. And of course, as we can see in our modeling, we did add an atypical event. And actually, that atypical event around 72 hours of very low renewable output and very high heat demand, you can see the energy systems coordinating to make sure the cost can be as low as possible. But actually, it is a critical driver of what kind of energy system we need to have in the future. That even though it's only a 72-hour period in a whole year, but that really drives significant investment into that system to make sure that there is adequacy. So what I want to ask, I guess, is kind of system adequacy and resilience becoming more important in the context of net zero and integrated systems? And should we be doing more, I guess, to embed these in planning and development, or are they happening anyway? So maybe, yeah, Keith, I'll start off with you, I'll give you a chance to go last in the last one.
Okay, thank you. That's great. I've got all my points I can make on this one. Lovely. Yeah, it's a really important point, and if we take the current design criteria for gas and electricity systems, they are entirely different, and you then start to work through what the connecting system is that links the two together, which can be data systems and communication networks and so forth, and they again have different design criteria to provide that level of resilience. It's really important that we start to wrap this together and create that overarching whole system model to understand that we're not embedding some new failure modes that we haven't considered, that we're not opening up new risks into this much more complex but hopefully more efficient system. So I think there's a piece of work to do there, really, to explore that, because we are always on the front foot in terms of cybersecurity. We've seen just recently issues across in the United States with these sorts of events occurring. The last thing we would want to see is almost that house of cards situation where we have this incredibly complex, highly efficient whole system, which can be brought down in a catastrophic way because we haven't carefully considered how this interconnection works and where the vulnerabilities might be. So I think that's a really important part to all of this. I think stepping back from that and the well explored issues of cybersecurity and so forth, there's then the issue around what the systems are designed to deliver. Now, from a gas perspective, that is designed quite deliberately to really high levels of availability, high levels of resilience, whatever the UK weather throws at it. And there's good reason for that. Vulnerable customers don't fare well if the heat goes off. So it's really important that from a customer perspective, there's a strong focus on delivering to support customers, particularly those with degrees of vulnerability. But equally, industry does not take kind to the gas going off, as you might well imagine. So the design criteria are really quite high. I'm sure they're equally apparent in the electricity system, but the electricity system currently serves a different market. So it's understanding the needs of the customer again, isn't it? And really making sure that for any new heat service landing on the electricity service or indeed transport, those considerations are stitched into the overall infrastructure makeup, so that we've got something that's fit for purpose for our economy, really.
Yeah, thank you, Keith. Moving to status, where are we, I guess, in the journey towards developing consistent resilience and quality of service requirements from a consumer's perspective and integrated systems? Are we early, midway, halfway? journey?
I would say I don't think there is an end to this journey, right? We'll start there. I mean, and what probably Keith mentioned, and I agree with him, because before my role at UK, when I was working in Ofgem, and I was focusing a lot on the gas transmission side of things. I mean, yes, the two networks have fundamentally different angles to build into them for very good reasons. I remember some of the planning standards go like in the 1 in 50 years events on the gas network, just to manage and cope, and facilitate, being able to allow people to pretty much have a warm house when things go wrong, or on a very cold snap. But I think that brings forward the conversation, and how do you adapt, for example, the electricity standards to make sure that if you have an increased level of electricity heating towards net zero, how do you adapt, the electricity network standards to meet that goal? I mean, we do bring forward in our flexibility services, the tangible benefit of a lot of those are targeted already towards the peak conditions on the network. So it will kind of try and address already and preempt those network stress events and address them at the same time. We also know that, there is, for example, electricity system, there is the capacity market to address that kind of adequacy questions for electricity. But that also means that there is a gas network behind it, or in the future a hydrogen network, if that exists, to a great extent, to support those. So I think this goes back to the whole system conversation, that yes, it's not one we are at the beginning or at the end. I think this is an ongoing conversation. We will have to pretty much help adapt standards, activities, and bring all the parties together to solve that.
Yeah. Thank you, Stats. Mel, do you want to comment on this?
Yes, Malcolm, on this. I think the first point to make is that the absolute priority is to keep the power flowing. And, as we move forward with the electrification of heat, the electrification of transport, that's going to be absolutely critical to keeping people's confidence in net zero, and in the big change that's ahead, and in the sort of behavioural change it's going to take to get people to make these large changes. So I think it's an absolute priority to make sure that we can keep that power supply going. And I think that we've proved quite well, probably over the past year, there has been a big change with COVID, and people's behaviors have changed quite massively, and the way they therefore consume their energy has also changed. And we've managed to maintain resilient supplies for that part of the year. So going forwards, it does bode quite well that we will be able to make sure that we are able to keep the standards up that we're going to need. I think going forwards, we're going to need to be even better, and making sure that we've got enough sort of fail-safe mechanisms in there to make sure that as we get smarter, we don't open up more vulnerabilities in our systems. So I think cybersecurity has already been mentioned, but that obviously becomes a much larger thing as we go forward. So I think that's something definitely to be looking at. But I do think that our overall approach as we move forwards, we are embedding these concerns into our approach. So things like cybersecurity are absolutely there, sort of front and center as we move forwards, looking at how we're going to test these new smarter electricity systems. So I'm confident that we'll be able to make the change and keep a safe, secure, reliable supply of electricity as we go forwards.
Well, thank you, Mel. So yeah, Roger, coming on to you, I guess we've covered a lot of area here around ensuring that we don't create new failure modes into the system, kind of consistency of standards across, and as Stathis said, it's kind of an evolving journey trying to understand and kind of embedding these practices. Would you agree? Anything else to add?
Yeah, I mean, my message would be customers don't need to worry about this. This is absolutely our job as the industry. They need to flick the switch, and everything needs to work for them. I mean, when it comes to flexibility, demand side flexibility in its own right, we already do a number of things to sort of mitigate unexpected circumstances. So we sort of efficiently over procure. So that's the event where we're not able to dispatch those things which are contracted for whatever reason. Under flexible power, which I think we've now got 5 of the 60, and hopefully 6 soon, using a common sort of terminology and procurement process for flexibility. We have a product called Restore, which is there for emergency use. So that's things which aren't contracted, effectively available to us in emergencies on a kind of pay-as-you-go basis. And then sort of up our sleeve, we also have a lot of flexibility within the electricity grid itself as well. So we can do things like manipulating voltages or change power flows to be able to create quite substantial amounts of flexibility should there be unexpected market conditions or unexpected network conditions, so that we can keep the lights on. You know, as Mel says, there's loads of things that, you know, people within our business worry about: cybersecurity, inertia, fault levels, failures, systems failures. There's all this, you know, great, you know, brilliant stuff going on. But as well as the worrying about it, also thinking about, you know, solutions to it as well. So there's bucket loads of stuff going on in the sort of innovation space. You know, we've got harmonic filters and virtual satcoms to be able to fix things. We've got DC power links to be able to, you know, shift power around and manipulate power flows. So I kind of sleep well, really well at night. I don't worry that we're heading into some kind of abyss because we're going to have too much flexibility and, you know, the markets are going to make us all doomed, because they absolutely won't. It's our job to keep the lights on.
Great. I think it's a great closing line for this question, Roger. So yeah, again, thank you very much. I think again we picked up quite variety of kind of different perspectives on kind of what does system resilience mean in integrated systems and what do we need to worry about. And also, I guess good to hear that, Roger, from what you said, it's kind of, you know, front and center for the energy networks in terms of what you've been doing and thinking about. So I think there's kind of one audience question which I think I'll pick up, and I think I can cover that off, and then let's pick up some of the questions again. So I think the one question is around, which I think is quite important, given the report is you know, what we thought to do was for it to be a robust evidence base, is that the report is kind of funded by, you know, gas and electricity utilities, of course, the partners here. You know, you've supported the project, and how did we kind of maintain the neutrality of scenarios, and how did we avoid over advocating scenarios that supported maintaining existing gas networks for hydrogen or new tech like CCS and hydrogen? I think it's a really interesting question. I think the first thing to say is the work is not advocating any single energy future, and also it's impossible to do that. There's so much uncertainties in how the energy system is going to develop. There are just still multiple open pathways of how we could do it. So actually, the intent of our work, and also Carbon Trust is, I guess, a mission-driven organization whose objective is to see the transition to net zero happen as cost effectively as we can. That's the overriding objective of us as an organization, and therefore the work was meant to kind of open up the different ways by which potentially we can meet net zero, and then fundamentally looking at the role and value of flexibility. Everything else is kind of essential context, but the real focus of the work is understanding the role and value of flexibility in different futures. So that's the reason we have, you know, 3 scenarios and numerous sensitivities, that because there is no real one answer of what exactly the energy system is going to look at. And there are several, you know, points in the analysis that says, you know, if you do not have CCS, what happens? If you do not have hydrogen, what happens? You know, if you don't develop carbon negative technologies, what happens? So we're trying to cater to kind of multiple belief systems of how the energy system could potentially develop, and within that context, understand the role and value of flexibility. So hopefully that helps to kind of create a little bit confidence of the work and how it can be used by everyone in the energy sector, that it's not pushing one particular agenda. So coming back to the questions, I think the one common thread across all of this question has been really consumers, that you have to keep the consumers at the center of it, whether it's resilience, whether it's digitalization, you know, whether it's kind of market development, flexibility, etc. So kind of moving beyond technology, I would like to discuss the role of consumer in all of these future energy systems. I guess a couple of context points is, one is the majority of the flexibility going forward from our analysis seems to be, you know, quite distributed. So it's not standalone assets that you can contract directly with. Actually, these are embedded in people's heating systems or people's transport systems or everyday appliances. And also, as we said, there's a lot of system development that needs to happen. You know, can we realistically keep the complexities away from the consumer? And kind of what does the value proposition for them to engage with this in the most effective manner look like? So that's really the question I'd like to explore a little bit detail. So Stathis, can I come to you to kick us off, please?
Yeah. I will start with what Roger said. I think in the first kind of, you know, the beginning of this conversation, that, you know, customer proposition and, you know, making things simpler for the customers is very important, because otherwise you're just gonna find obstacles in delivering net zero. The idea being that we, for example, as electricity networks, we will interact with the heat and the transport system anyway. And so we need to facilitate those customer propositions, not necessarily directly through us, but through us in making that transition. I mean, the electric vehicle strategy we have pretty much is working with aggregators to allow them to deliver effectively the electrification of transport as is required, but in a way that's tangible for the end consumer, that they can plug their EV and charge it when they need to, and then at the same time support the network in a manner that works harmonious for everyone. One thing that came to mind, because we had a discussion, I think, last week with another couple of colleagues at the office, was because I did go to the office on occasions. It was that there is an innovation project effectively with West Wales and West to create a hybrid residential heating system, to pretty much bring that flexibility of the whole system at the residential level, so that will actually help create solutions and pathways towards what net zero is about. Because yes, if we knew all the answer what net zero is about, we wouldn't be here discussing about it. We're just thinking of delivering that. But the idea is to create the pathways, because we have to explore those pathways and create them, so we manage the transition to net zero. I mean, we did touch upon earlier, I think, on the local authorities as well. I mean, this is also important, right? Because we will definitely need to make that proposition and bring together local authorities on board in this journey, right? We are the more, let's say, technically minded people in this conversation. We also need to bring the people who actually deal with the end consumer and help those local plans come to fruition towards net zero. And it might be different in different cases, in different regions. Within each, let's say, DNO or gas distribution network operator, different plans, right, come to fruition. But that's the whole idea, that net zero is a whole picture here.
Great. Yeah. Thanks, Tatis. Roger, can I come to you, please? Because I know you've brought in that consumer angle in across the question. So it'll be really good to understand, what does that kind of evolving value proposition look like?
Yeah, we want to make sure that we are beginning to shift more and more of this flexibility from the generation side to the demand side. I mean, that's what your report is also showing, and that does mean we start going quite deep into consumer homes and their lives, be it heating or their electric vehicles, that kind of smart appliances. What as I've said before, what we've got to make sure we do is we allow a market to develop that delivers propositions that consumers actively want. So I'm old enough to remember the old-fashioned storage heaters. There's actually quite a lot of the old-fashioned storage heaters around, and they were renowned at delivering heat exactly where you needed it, but not when you needed it. Because they didn't actually store heat, they actually leaked it out during the day. So when you came home in the evening and sat down and watched the day, they'd run out of heat again, and you were cold. And there's a real risk that if we all get really excited about all electric future and we just have heat pumps with a flexibility market and dynamic pricing, that we'll get to a point where you can have your heat pump, but lots of people in society won't be able to heat the homes when you need it. You'll be able to have it when you're not there or after you've gone to bed, and that's not progress. And as a society, we should be focused on making progress, not going backwards. So why this is relevant is that if therefore somebody can invest in an asset that's a thermal store, for example, that goes along with a heat pump, and I can pay the same money as I would have done for my heating system that doesn't deliver heat when I need it, and someone else pays for the thermal store because it can offset a load of cost in capacity market or networks or somewhere else. All of a sudden, we're getting more and a better quality service for the same money, or potentially less money. And this will start being attractive. It's only once we get this consumer pull that these things will really take off. You could say the same with electric vehicles. Most people in Britain lease cars under PCP or some sort of financing type arrangement. Many cars come with different ranges on the battery. If the one with the bigger range is the same price as the one with the smaller range, because someone else is putting the additional capital, again, why wouldn't you? And again, you're getting consumer pull and gaining access to flexibility. So it's for us in the whole industry, it's about making our system work in a way that supports the developments of these markets. So, back on the digitalisation, and that's why we're so keen to hear from people as to what they need. People can tell us what they need. We can make that information available, and these markets and propositions can actually develop. This isn't about some sort of, state-run monopolistic rollout of low carbon stuff at low cost. This has got to be about going forwards, not backwards as a society, Manny.
Yeah. So I think the theme is around kind of developing markets that kind of opens up participation, makes it easy for people to engage with, and kind of the heating and transport decarbonization becomes more cost effective, and also actually potentially returns value to customers. That's probably the way we're going to kind of land this. I think that's really interesting point. Mel, can I come to you for that? And it'd be really interesting to hear kind of your views on kind of user propositions and how we engage with them to unlock this flexibility.
Yes, no, absolutely. So for me, we're at an absolutely pivotal point at the moment in the energy transition. We've got sectors of society that are going to be able to afford to have electric vehicles, put in solar panels, really benefit from this energy transition. And then we've got other areas of society that maybe aren't going to be able to participate in that way. And we have to be really careful that we're creating a system that is socially equitable across the board, that everybody can participate in and everybody can benefit in, especially as we come to look at our sort of charging regimes and how they're likely to be changing in the future. So I think my first point would be around social equity and making sure everybody can access these markets and can actually participate in them. Otherwise, we're going to end up with a bit of a two-tier participation, which is not going to benefit everybody. So making sure that nobody gets left behind in the transition is something that we all have to look at together. I think my second point is we've talked a lot about, partnerships in terms of infrastructure and, your local authorities, your network companies, etc. But I think it's really important to build good relationships with people like Citizens Advice, with the sort of organizations that people trust, so that we can get much wider consumer engagement and find out what it is that people really want and how they're going to be able to benefit going forwards. So as part of the LEO project, we've got a stakeholder advisory board that has a really diverse population on it, and it's really helping us to see the transition through a lot of different lenses. And I think that probably brings me on to the other piece of work that we've been doing with the Centre for Sustainable Energy, and that is the Smart and Fair project. So very much looking through what we're calling capability lenses. So what is a person's capability to be able to actually participate in these markets? Are they familiar with apps, for example? Do they own their own home? And through these sort of exploratory trials and pieces of work, we'll be able to work out where the gaps are, where people might be falling between the cracks, and how we can help to address that through the policies that are being advocated going forwards.
Okay. Yeah. Thanks, Mal. I think that's super helpful. And then maybe coming to Keith. Keith, I know we're kind of running out of time as well, and I don't want to lose the opportunity not to discuss one of the key aspects of this around kind of the infrastructure coordination required for hydrogen. So kind of give you an option to kind of either start with this question and move already into it, but I'll kind of lay out the question because it'll be useful to get some other views as well on that, which is again from this kind of work we show that to kind of deliver hydrogen cost effectively. One, I guess flexibility is really important, but also it requires very careful coordination between the gas system, the electricity system, and also carbon negative technologies in use. So it'll be really interesting to understand from you how we should approach hydrogen development in the short term, so 5 to 10 years, from this integrated perspective, so we give it a chance of kind of delivering against net zero in a cost effective manner.
Yeah, okay. Well, I'll just very quickly touch on the customer question first, because I do think it's a fundamental really that we get this right for the consumer that's out there. A lot's already been covered, so I'll not dwell on that, conscious of time. But one area that we do need to focus on is one of knowledge. Through the research that we've had undertaken through our H21 programs and in collaboration with the other networks and HiDeploy, using academics to go in and have those conversations. So not with us, but with that sort of that fire break between the utility and the consumer. It comes across really clearly that there's a bit of a knowledge gap here, where experts in utilities are in terms of net zero and the planning and all the technology and so forth. We are somewhat blessed in terms of having a pretty solid understanding of what current next steps and future look like. Consumers are nowhere near that level of detail. So there's a real there's a knowledge gap there that they need to be properly informed so that they can make the right choice. And of course, the consumers value choice. They've had that for many years now, and it's a key driver of keeping costs down. In terms of switching and making the right technology choices. So cost, impact, flexibility. Not being dictated to about when you can't use your systems and so forth. All of these are coming across loud and clear to us that they are key, important parts of the consumer mindset, and which are really cherished. So any changes to those things, any changes at all, got to be really carefully considered and take the consumer with us in order that we have a successful outcome. I think the other thing, and Mel touched on that, was this kind of blanket term of customer consumer. There are so many different situations out there, from those in dire fuel poverty situations where they're making everyday choices about whether they heat or whether they eat. These are real world situations where they don't have access to the technology, and the circumstances are very, very difficult. We absolutely have to make sure that they have the same ability to buy into this as everyone else. So it's really key and important piece of work, and something that we are continuing to research and support as our thinking on hydrogen progresses. So getting on to what's next for hydrogen. Industry is carrying out a huge amount of work at the moment. There are several projects in play, from H21 looking at how you repurpose the existing infrastructure, to the H100, our colleagues in Scotland looking at putting some new infrastructure into a village, a couple hundred connections, really to understand the logistics of delivering this. Meanwhile, while all of these projects are going on from the industry down to the domestic, we're looking at how do you transform the system? We've got as it is with electricity, this kind of top-down approach where we've got product coming in at one end, it goes down several tiers, and it ends up through the meter into a consumer's appliance. So we've got that system at the moment. In order to carry out that conversion process, there's elements where you've almost got to tip that upside down, as you mentioned, and start simply by creating through clusters hydrogen that can be rolled out in ever expanding footprint. And I think that's one of the areas that we're looking at right now, that cascade effect where you slowly go up the various pressure tiers in our case, in order to remove the reliance on natural gas and cut across to hydrogen. Now, clearly, there's going to be a range of different options there, and geography will play quite a large part in what happens where and at what pace. So you can certainly see major urban centres being targeted if they happen to be near some industrial cluster where there's a massive production of hydrogen already. That looks like an obvious place to start. But we may well start to see, hotspots of hydrogen, local installations popping up, private operators coming along who feel they've got a business model that would work. So there's a range of options out there. In terms of the timescale for all of this, really by 2025, we'll have had a hydrogen village type, one or more hydrogen villages in operation, testing the appliances, the processes, the procedures, the standards, and so on. We've seen from government an ambition to have hydrogen town by the back end of this decade, which obviously is into the many thousands at that point. And really, in line with that, you're starting to get to a position, certainly by the time you get to Hydrogen Town, where the safety cases are in place, the logistics, the supply chain is built up, and you can then start to consider the rollout program from the back end of this decade through to 2050. So that gives you a sense of where we are. I think there are some key questions, just to finish off, around the production side. Where will production be based? What scale will that be? And so on and so forth. Because one thing that's quite clear is the heat demand is absolutely vast. We're talking, in the terawatt hours per day, 4 or 5, typically during the winter period of demand for heat energy. So this ain't small beer, and finding the right answers to all of this is really key right now.
Brilliant. Thank you, Keith. Yeah, I might just maybe get some kind of brief reflections on this question, and then also probably want to give an opportunity for closing remarks from all of you. So maybe Mel, very quickly, if there's kind of anything from an electricity networks infrastructure perspective, how you're engaging in the short term with the hydrogen development journey.
Yeah, so I think when it comes to hydrogen, it's really important that we look across the board. There's no one size fits all for the energy transition, and there are industries that are going to require hydrogen in order to keep running. So that's absolutely fundamental. I think there's a lot of good projects out there for hydrogen, which we wholeheartedly support, and I think we need a range of technologies to be able to move forward with the decarbonisation agenda. So, looking at the different sorts of products that are out there, things like electrolyzers are certainly going to be the kind of interface, as it were, between the electricity system and the hydrogen system. So, working out what that contribution can be going forwards, how we can help them as a sort of a one-way, hydrogen creation system, but then also as kind of a storage system as well. So looking at those two options to sort of move energy between the two systems and how that works, from a physical perspective, but also from a sort of cost optimization perspective. Those are the things that we're going to be looking at on the distribution network for hydrogen specifically.
Thank you, Mel. Roger, do you want to add anything to that?
Yeah, you want to try and tee me up at this point to do down hydrogen and talk about electric only, but I'm not going to fall this time, Manny. I genuinely believe electric future isn't a viable pathway. No more is it than it being a viable pathway. The whole of the natural gas network is going to all switch over to hydrogen. The truth is, it's going to be somewhere in between. The main thing on hydrogen is that if you think of it as sort of an egg timer in delivering net zero, the sand is already running through the egg timer, and somebody's shoving the sand out the top, aren't they, as well? These dates for hitting net zero are only going to be coming sort of forwards, and so hydrogen is a worry. I'll go on record as saying hydrogen is a worry. It's a worry because I feel there is a need for even more investment in urgent research, probably approaching the scale that we've been doing on vaccines. We need to make rapid progress. We can't be taking decades to think about further research, and there are significant technology gaps. Whether it's the viability of producing large amounts of green hydrogen, whether it's the carbon storage and utilization associated with blue hydrogen, we have solutions to problems that don't exist, where the technologies don't exist. So I'd like to see a rapid ramp up. I'd also like to see early investment in green hydrogen, in electrolysis. We know we need electricity, we know we need water, and we know we need gas pipes to put the stuff in. And for me, we ought to be starting as a nation to talk about the creation of strategic hubs for green hydrogen production, and begin building out the 3 lots of infrastructure that we need to get these 3 vectors together. Government regulate all 3 of those grids, and therefore hold all levers they need to be able to crack on with this with very, very low risk of stranded investment.
Great, thanks, Roger. And kind of you saw my question coming from a mile. Status to you.
Yeah, I think if we start just to give a positive spin to what Roger was saying, I mean, the fact that the government has included hydrogen in their 10-point plan is something positive. There are obviously the difficult questions are that how do you introduce it either in existing networks, especially it's harder for the transmission, the gas transmission network to pretty much get hydrogen in it because of the brittleness of steel. But that means there are what Roger said about technology research and pretty much create the framework there to come stronger. That's absolutely critical, I think, and that brings also what we discussed, I think, across many areas already, that discussing this with and engaging with local governments to see where these become more viable propositions is probably the critical bit. Because it might be in some areas, maybe not in other ones, whether you include hydrolysis or any other means of storing renewable energy in hydrogen, and then you pump it back and you consume it as electricity, for example. That's these are questions to which we don't have the answers currently. I mean, the role is definitely there, but it's things that we need to explore further.
Brilliant. Thank you, Stathis. I think that brings to an end the panel discussion. I think I'd just like to take the opportunity to thank all of you for taking the time and coming and discussing these really interesting topics. I thought an hour and a half was too much, but given the range of the topics, it looks like we can kind of easily go for another few hours. But I would really like to thank you, Stathis, thank you, Mel, Keith, and Roger for coming today and sharing your views. Thank you very much. I'll hand over back to Janet now.
Thanks very much, Manu, and I agree. It was a really fascinating discussion, and I could listen for a lot longer. In fact, it was full of interesting stuff. But I'll just pick out a couple of things that struck me. One of the key issues was this issue about digitalization. And the need to stitch both it and security in to everything that we do. And I thought it was interesting that although the panelists might be seen as a fairly homogeneous group because they're all networks, they are clearly taking different approaches and at different stages for different parts of the digitalization journey. So that's an interesting dynamic. The second thing I thought that stood out was the need to think about energy planning, consider who does it on a local scale, and who's got the expertise there. And I think that's an important point when we think about the interplay between electricity and hydrogen. And not just that, but I think it was a very good reminder that there are some very big users out there who are at the heart of this flexibility journey. The water companies are indeed a very good example. They use a lot of energy, they do a lot of pumping, and that's a load that can be shifted if you're working together. And finally, I think I'd just like to highlight this brilliant shift that's happening in the networks from talking about technology to talking about customers and markets and how that will move forward, and in fact what customers want out of it. And again, another very interesting point is that utilities and the networks are doing this now, and there's a big gap between what they're thinking, where they're at, and where customers are at, and whether they're domestic customers or business customers. And I wonder whether this discussion of local energy hubs and local energy planning could perhaps help to bridge that gap. But these are issues that we'll carry on discussing, I'm sure, for a very long time. But unfortunately, we have to bring the session to a close. We'll come back this afternoon to talk about some of these whole system issues, which is a very good planning by the Carbon Trust. That flows very nicely. In the meantime, do use the break to explore the on-demand content. If you go to the main homepage and click the resources tab, you'll find the Flexibility in Great Britain report and some other resources. Other than that, I look forward to seeing you this afternoon, 2 o'clock for Whole Systems. Thank you.